Hey guys, welcome back. In the last video, I did examples of the quotient rule and we ended with deriving the derivative for tangent theta by using the quotient rule. And in this video, I'm going to teach you guys how to figure out what the derivative of cosecant theta, secant theta, and cotangent theta are by using the quotient rule. So if you guys want to give it a try by yourself, press pause and see if we come up with the same answer, okay? So use the quotient rule to find the derivative of f of theta equals cosecant theta. So first thing is I'm going to rewrite it, and that's going to be 1 over sine theta. And now I'm going to use the quotient rule. Well, we're going to keep the bottom, derivative of the top. Do you guys remember what the derivative of 1 is? It's 0. I'm going to go like that. Keep the bottom, derivative of the top, minus keep the top, derivative of the bottom. Do you guys remember what the derivative of sine theta is? Cosine theta. All over the bottom squared. Okay? So now, to clean this up a bit, this part right here cancels out, 0 times sine theta, and you're actually left with negative 1 over, cosine theta over sine squared theta. Now I'm going to do something here. I'm going to write sine squared theta as sine theta times 1 over sine theta. In other words, you can see that this part here gives you sine squared theta. And the reason why I did that is because I prefer to write it in terms of cotangent and cosecant. So the derivative, this guy right here, is going to be cosecant theta. And this guy right here is going to be cotangent theta. And there's a negative, so I'm going to put a negative. Therefore, we can conclude that the derivative is negative cosecant theta, cotangent theta. Okay, so that's how you figure out cosecant theta. What is the derivative of secant theta? Well, same exact procedure. We're going to do 1 over cosine theta. We're going to do the quotient rule. And we're going to keep the bottom, derivative of the top, minus keep the top, derivative of the bottom. Do you guys remember what the derivative of cosine is? Negative sine. All over the bottom squared. We're going to clean this up a bit. This cancels out. You're left with positive sine theta over cosine squared theta. And what I'm going to do here is I'm going to do the same steps. I'm going to separate the denominator. Okay? And so I'm going to finish off with secant theta, tangent theta. And therefore, we know that the derivative of secant theta is secant theta tan theta. We know the derivative of cosecant theta is negative cosecant theta cotangent theta. And our final one is cotangent theta. And the derivative of cotangent theta, well, I'm going to have to first write it as a quotient. So that's going to be cosine theta over sine theta. I'm going to do the quotient rule. And that's why I put this prime here to show the reader or the person who's looking at your paper that you're about to take the derivative. In this, all I did was rewrite it. So now we're going to do the quotient rule. We're going to keep the bottom, derivative of the top. The derivative of cosine is negative sine. And now minus keep the, so we kept the bottom, derivative of the top, minus keep the top, derivative of sine is cosine, all over the bottom squared. Let's see what that looks like. We're going to make that negative sine squared theta, negative cosine squared theta, all over sine squared theta. I'm going to factor out this negative 1, and I'm going to be left with sine squared theta plus cosine squared theta, all over sine squared theta. And if you guys remember from trig, this identity here, this guy right here is 1, right? So I got negative 1 over sine squared. So that's just going to be Negative 1 over sine squared is negative 1 cosecant squared theta. And that's how we do the 3 trigs. Now, I'm going to show you guys the best way on how to remember this. The best way. Here's what we're going to do. You guys ready? First, we have sine, cosine, tangent. This is how you guys are going to remember it. Then you're going to put the reciprocal of tangent as cotangent. The reciprocal of cosine as secant. And the reciprocal of sine as cosecant. All right, here's the trick. You start off plus, minus, plus, minus, plus, minus. Okay, that's your first step. Everything that starts with a C gets a negative for its derivative. Now, sine and cosine are the most basic. These two are the most basic functions that we have. So they get each other. So sine gets cosine and cosine gets sine. So just remember, we already took care of the SIGN, the sine. Tangent and cotangent are the most powerful. Therefore, they get powers. In trig, secant and tangent always go together. So tangent theta gets secant squared theta. Cotangent theta gets cosecant squared theta. Now, secant theta and cosecant theta, they are not weak and they're not powerful. They're in between. So they actually get themselves and someone else. Well, guess who secant gets? Secant gets tangent. And guess who cosecant gets? Cotangent. Secant and tangent always go together, just like cosecant and cotangent. So that's how you do it. That's the easiest way. Make sure you have to write them in order. Reciprocals come right after in reverse, okay? Plus, minus, plus, minus, plus, minus, weak with weak, powerful with powerful, and in the middle for both of them. All right, I hope this was helpful, and come back for the next video.